All right, so our learning goal today is to be able to solve multi-step first degree equations. So we already looked at simple equations where we're isolating x. No matter what kind of equation that we have, we're trying to ultimately determine what is the value of x that will make that equation true. So our focus today is going to be on multi-step, meaning there's more than one, more than two, sometimes three, maybe even four steps to solving that equation. All right, so one way this question is often phrased is find the root of each equation. If you ever see that, it means the same thing. Figure out what answer is going to make this true. In example A, when we look at what's happening, I have 3z minus 12 equals 2z plus 5. What's different compared to yesterday when we did our simple examples, there's a variable on both sides. Our goal is to be able to isolate. So I want to get that variable on the same side. So when I look at these two numbers, the 3z is the bigger value. So I'm going to leave that where it is. But 2z, I'm actually going to subtract 2z from the left side and the right side. You'll notice I'm lining that 2z up underneath that 3z because they're like terms. If I have 3z and I take away 2z, I'm going to be left with z minus 12, because that's still there, equals, the whole reason why I chose to subtract 2z is because 2z take away 2z is 0, and all that's left on this side is 5. Now we want to get z by itself, so I still have a subtraction of 12, so the opposite of subtracting 12 is going to add 12, so I'm going to add 12 to both sides. So z equals 17. Now, if we were to do the example in letter B, it's the same idea. But in this example, instead of moving the 2x like I did in letter A, I'm going to move the 3x. So just to show you a different way of doing it. So the 3x is here, it's positive. The opposite of an addition of 3x is a subtraction. So I'm going to subtract 3x here. I'm not going to put the 3x underneath the 4. I can't put it there because 3x and 4 are not like terms. So that means I'm going to put the 3x underneath the x. So when I do that, 3x take away 3x, 0. I have no more x's on that side, and that's what I want. That minus 4 is still here, and then that's going to equal 2 take away 3 is going to be negative x, and that plus 4 is still there. Now we want to get that 4 over to the other side because our goal is isolating the x. So the opposite of adding 4 is subtracting 4. So I'm going to subtract 4. I have minus 4 take away 4 is going to be negative 8, and then that equals negative x. So we have a little problem. We don't want negative x as our answer. We want to have positive x. So remember, we've talked about before, there's like a 1 right here. So mathematically, to get rid of that negative 1, we're going to divide both sides by negative 1. So 8 is equal to x. Now I'm showing this very linearly where I'm just moving down. There are a bunch of ways of showing your work when you're solving these equations. So depending on how you want to show your work, there are multiple ways. All right, so let's look at a couple more examples. In this example, you'll notice there's 3 different terms that have x. So in a situation like this, in the other examples, both sides were already simplified. But in this example, on the left side, I have negative 23x, and I have negative 3x right here. You should always simplify first. So when I combine those values, I'm going to get negative 26x plus 12 equals 7x minus 23. So always simplify first before you start moving. Okay, so now when I look at this here, I have x on both sides. So now I'm back to doing the exact same thing I did in that previous example. So I'm going to subtract 7x from both sides. So I'm subtracting 7x from both sides because that gets rid of the x. So negative 26 take away minus 7x is going to give me negative 33x plus 12 equals minus 23. So once again, now our goal is to get the x by itself. I've got them all on the same side, but now I need to get that x by itself. So that addition of 12 here is preventing me from having the x all by itself. So I'm going to subtract 12 from both sides. So I get negative 33x equals negative 35. So negative 23 take away 12 is going to be negative 35. Now, our goal, again, we don't want to know what negative 33x is. We want to know what x is. So the opposite of multiplying by negative 33 is dividing. And what I do to one side, I have to do to the other. So I have x is going to equal, the negative and a negative becomes a positive. So my final answer is 35 over 33. And I'm going to leave my answer like that because it's a reduced fraction. I'm not going to change it to a decimal. I'm going to leave it as 35 over 33. Now, this is not the only way to do this question. Like I said, you could have moved the 26 instead of the 7 to start. So it really depends on how you're going to see. However, in my experience, most students like keeping their variable on the left side of the equal sign. You'll also notice I'm not putting equal sign as soon as I start a new line. I'm keeping that equal sign just in the middle because we only have one equal sign per line. All right, let's look at some more examples. So now in this one, I have a bracket. So just like before, whenever we were expanding, we want that bracket not to be there. So that's your first step. So when I do the distributive property, I'm going to have 5 times x to give me 5x, and then 5 times 4 is going to be 20. So the first step I did was I got rid of the bracket. Now I want to get the x's on the same side. So I'm going to subtract 3x because this is a positive 3x and the opposite is a subtraction. I'm writing it under the 5 because of the like terms. 5 minus 3 gives me 2x plus 20 equals 14. Because 3x, take away 3x, I've accomplished what I needed to do. I don't want a variable on that side. So now I'm going to subtract 20 because that's preventing the 2x from being by itself. And just like lifting weights, what I do to one arm, I'm going to do to the other. So I have 2x is going to equal negative 6 because 14 take away 20 is negative 6. I have one last step here. So I'm going to divide both sides by 2, and then that will give me my final value of x. Oops, not 2. 6 divided by 2 isn't 2. 6 divided by 2 is 3. Now something I haven't done a lot of is I haven't checked a lot of answers. So I'm going to go ahead and check this answer. So I'm going to write that over here. So for my check, I'm going to have 5 bracket, x has a value of 3 plus 4 equals 3 times 3 plus 4. So I'm going to have 5 times 7 equals. Okay, so I have another mistake, and I'm realizing that as I'm trying to do my little check here, I'm not going to get the right answer. So actually, let's continue and see what happens. So 9 plus 14, so 35, does not equal 23. So that means I made something, or I did something wrong. So now when I go and I look, I see what my mistake is. Negative 6 divided by 2 is negative 3. So I need to change that. I need to go back and make sure that it's a negative. So now when I do that check, I'm going to have 5, negative 3 plus 4 equals 3 multiplied by negative 3 plus 14. So 5 multiplied by 1 is going to equal negative 9 plus 14. 5 equals 5. That's good. All right, so there's a situation where checking your answer can show whether or not you got the right thing happening. In this last example that we have here, I'm just going to flick over here for a second. We have three sets of brackets. That doesn't change anything. We're still going to multiply through. So I have 4m plus 12 plus 2m minus 6 is going to equal 3m minus 6. Now you're probably wondering, should I simplify? Yes, always, always, always. 4m plus 2m is going to give me 6m. These two terms are the same. And then I have 12 here, and I have minus 6. Positive 12 take away 6 is going to be plus 6 equals, the right side is already simplified. Now we're back to those same examples where I'm going to subtract 3m. So I'm going to have 3m plus 6 equals negative 6. I want the m by itself, so I'm going to subtract 6 because that gives me a value of 0 when I combine those terms. So 3m equals negative 12. And finally, the opposite of multiplying by 3 is dividing both sides by 3. And I won't make that same mistake this time. I get negative 4 because a negative divided by a positive is negative 4. So really, for our questions like this would be the maximum number of steps that you would have to do. So I would say this question would be worth 1, 2, 3, maybe 4 marks. So between 3 and 4 marks, depending on how many different brackets and how many steps. However, very procedural. Now, the question I'm going to ask is, does there have to be a solution? So if I'm looking at this, I have x plus 5 equals x minus 2. Is there any number that I can put in for x that is going to make this a true statement? The answer is no, not in this case. Because if I follow the process that we kind of developed on the other slides, I have x, I want this x to move. So if I subtract x from both sides, I'm left with 5 equals negative 2. Is that true? No, it's not. So does there always have to be a solution? The answer is no. Sometimes there is no solution. And you'll know that's happening if you end up with a false statement. And by false statement, I mean 5 cannot equal negative 2. There's absolutely no number that is going to make these two equations equal. Now, on the flip side, can there be more than one solution? The answer to that is yes. So if I simplify this here, this right side becomes 3x plus 3 because I'm dividing the numerator by 2. I'm breaking it up into 6x over 2 to get 3x and 6 over 2 to get 3. What do you notice about these equations? They are the exact same thing. So if I follow my process and I subtract 3x from both sides, I'm going to be left with 3 equals 3. Does 3 equal 3? Yes. So this is what we call infinite solutions. Because no matter what value of x we pick, it's always going to be true. This will happen when you have the exact same thing on the left and on the right. Now on worksheet 4.2, you're going to do number 1 to 11, A to C, in questions where there's multiple questions there. Some of them there are just the question itself, so you'll complete that. But in questions where there's multiple ones, then you will complete all of those. So hopefully this makes sense. If not, you know where I am at lunch.